All right, so welcome everybody. We're on Zoom. Welcome everybody in the lecture hall. So we are going to continue today the lecture on querying trees, right? So the idea is this. I put again the few slides that we had last time, with the idea that if you use SQL and if you use relational databases, then the data is highly structured. Right? So you have, you basically have tables that have rows, that have columns, and it's all flat, it's all homogeneous. You always have the same type within the same column. But we saw in big data that something happens that the data might not be like that because it's accumulated with logs and so on. So what is going to happen is that you might have extra values here, you might have missing values, and you might have invalid values because maybe you have strings here and then you have an integer and so on. And you might also have nested values, meaning tables in tables in tables. So we saw that this is a big limitation of SQL. We have systems actually accommodate for that, like MongoDB. The problem is that these systems do not have a high-level language, like SQL that you would have for such tables. So now we are looking at the missing elements, the last one. That is a language that provides you a way to query this sort of data, but on an abstract level, with a high level. Right. So this language is called JSONic, and exactly like SQL is implemented on top of relational databases or even on top of HBase and so on. In that case, we implement JSONic on top of Apache Spark. It could be also on top of HBase, on Hadoop, or pretty much anything. And this implementation actually was done at ETH, the one we will use in the course. It's actually called RumbleDB. It started with a master's thesis. Now it's been 5 years, so 5 years ago. And then maybe 15 students participated in that project, extended it, and turned it into an actual release. It's free, it's open source, and it can be used to query data, right? So I showed that it's like a data calculator. You know, when you use a calculator, you can type 1 + 1, 2 + 2, and so on. And when you do that, you get the results. Well, it's pretty much exactly the same thing as a data calculator, in the sense that you can actually have JSON instead. So here are a few examples where you have an actual numbers, right? So 2 less than 5, this is all JSONic, right? You can define variables with a let and a return. So you define that I is assigned to the value 2, and then you return I + 1. So that's 2 + 1 gives you 3. And then you can actually copy paste literally JSON in there. So this is a JSON array, and you can put it in that data calculator, and that returns the same array. You can put an object, it returns the object. But when it becomes interesting is that just like in a calculator, you have plus, minus, multiply, and so on. Here you have the dot. And if you have on the left, in that case, one object, and you say .foo, not surprisingly, just like in JavaScript or Java, it will extract the value associated with the key foo and return 1. So the same way we can navigate arrays with these double square brackets. So if we take, in that case, the first position, so it starts at 1. So this is position 1, position 2, position 3. So with this, we take the item in the first position of the array, which is 3, and return 3. And here, a bit more complex, we have an object with foo associated with an array of integers. And if I take this object and say .foo, that's going to give me the array, then I extract the first value in the array, which is 3, and then +3, 6. So you see, it's just like generalized mathematics, but it's a mathematics of data. Here's another example with just empty square brackets where you extract the value. So here, .foo gives you the array, and then this opens the array and extracts a sequence. So we'll see that these sequences in the language are really at the core. You also have operators that's actually useful to iterate, like 1 to 4 is just going to generate the integers from 1 to 4. So you can do, of course, 1 to 1,000 and so on, right? So this is for 4 clauses, as we will see. And here's an example for $I in 3 to 5, return. And you see here how it's dynamic. It basically looks like JSON. It's like a JSON object, but you see that the key is generated dynamically. every time we are going to use $I as the key and put the square of I. So here I get 3 associated with 9, 4 associated with 16, and 5 with 25. Now, something interesting happened in there is that this is an integer, but the key in a JSON object must be a string. So the integer got converted to a string automatically, right? So this is how it works. Are you following? Here is just the appetizer. I will go in details on the language. Last time, one of you actually asked a very interesting question or had a comment on how it's different from Python or JavaScript. And the way it's different from Python and JavaScript is pretty much this idea that it's a data calculator. The idea is that it's a functional and declarative language, which all query languages should be. Functional language means it's a language that assembles like Lego. The idea is that in JSONiq, you can take any expression and put it inside any other expression. Just imagination is the limit. Right. So this is what functional means, and then it's just evaluating the results. Declarative means that instead of telling the system, do that, assign this value to that variable, and then add this, and then update this value, and then write this, and then do this, and then do that, and then do it 10 times, and so on and so on, that's imperative. That's like Java or Python would do it. In a functional language, you never do that. In a functional language, you just say, here's what I want. So the difference would be a bit like if you cook at home, that's imperative. You have a recipe book, you follow the instructions. They tell you do this, do that, do this, do that, pour the sugar, the eggs, blah, 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 and you follow the instructions. That's imperative. Declarative is going to the restaurant or to the Mensa and saying, I'd like the veggie menu, or I'd like this dessert, and so on and so on. That is declarative. And the beauty of declarative languages and functional languages is that because you don't specify the details, you leave that up to the system. The system is going to figure out the details for you. They're going to find the best way to execute it. In the case of RumbleDB, it will even be able to execute it in parallel on a Spark cluster, but you don't even need to see that. You don't even need to care about that because it's all automagical. Right. So this is the main idea. And coming back to that for loop, this is not a for loop in the sense that you would have them in C++ or in Python. In C++ or in Python, the for loop would basically be start with 3 and then do this and then go to 4 and then do this and then go to 5 and then do this. But here, this is not what's happening. Here, all this is saying is that mathematically, we are mapping as a mathematical map, mathematical function, each one of the values between 3 and 5 to a value computed that way, and then we are concatenating the results. This is really a concatenation, and this is not a sequence of instructions. That's the main thing to understand. But I'll come back to that, right? Don't worry. I'll come back to these clauses. It's basically the equivalent of select from where in SQL. All right. And so you see here, I said 3 to 5, but I could also say here's an object, and then .foo, and then I open the array, and that basically does the same thing. Then I iterate. So you see the essence of the data calculator. And then, of course, this is not very useful if all you can do is just input operations like that. It really becomes useful when you have a data set, like petabytes of data, sitting on S3 or sitting on HDFS, and then just with the JSON file call, you open that data, it views that directly as a sequence of JSON objects, and then it maps this JSON object. So for $I blah, 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 return, and of course, you can have something more complex than that. But basically, you can, in that case, extract the keys. You have the keys function that is extracting the keys of the objects. And maybe it finds out there's two keys, foo and bar. What happens here is that there might be 1 petabyte of data in there. There might be 1,000 machines in the cluster, and you get your response maybe in 10 seconds, just with these few lines. And the idea is that RumbleDB figured out how to execute it, mapping it to Spark transformations, actions, and so on and so on. So this is the high level. All right. So you can also read Parquet. And as we saw, Parquet is going to be much faster. This might be just 1 second. I don't know, because in Parquet, you can actually directly read the keys from the metadata in Parquet, as you know, right? The way that Parquet is structured. So this is going to be even faster. All right, so there's a whole ecosystem of languages. We are not going to look at all of them, but there's an ecosystem for XML, an ecosystem for JSON. It's a bit permeable, so it goes from one to the other. So for navigation, we have XPath, JSON path, transformation, XSLT. You might have heard JSON-T. On XML, the language is called XQuery. JSON is kind of the cousin of XQuery in a way. It's actually a spin-off of XQuery, but made for JSON. And there is also updating and scripting extensions. Just like in SQL, you have insert, update, and so on, right? In SQL, you can update the data. You can also do the same in XQuery and JSON, right? But today, we are really focusing on querying JSON here with JSONiq, but you'll see that learning the rest would be easy. Now, I have to say that when JSONiq actually came to life, that was more than 10 years ago, it was as part of the discussions to standardize JSON within XQuery, the W3C. Back then, there were almost no languages doing that. The reaction of people was more like, why do you need a language for JSON? There's already JavaScript. But these people were missing the point that JavaScript is imperative, not functional. Today, I think we are approaching 30 languages. And the reason is that people actually realized that we need a language for JSON. So now we have exactly the opposite problem, that we have too many languages. So it should at some point converge. Hopefully, it will be, there will be a standard like SQL. But in the meantime, we have to live with all these languages because pretty much every company just wants to have their own language. But don't worry, because the nice thing is that these languages are very much alike to each other. So if you learn one, you'll have absolutely no difficulty learning another one, right? It's pretty much the same principle. And I'm teaching you JSONiq because it's mainly made of a standards from the W3C, just like HTML. So it's a working group with bright minds from many companies like IBM, Oracle, Microsoft, and so on, who sit together for years designing all of that. And so I'm going to show to you what came out of that. All right? So that was just the intro. And now I'm going to take the time to walk you through the language, explain the model, and so on, and explain how that works. I'm going to start with the data model. Why do I do that? Because I said it's a functional language, like a data calculator. So as a functional language, it manipulates things. So I have to tell you what things it manipulates. What does SQL manipulate? On Zoom, what does SQL manipulate? Anybody on Zoom?
Tables?
Yes, absolutely, tables. SQL manipulates tables. Everything that goes into and out of a SQL query is a relational table. Even if it's a single number, it's still considered a table with one row and one column, right? So indeed, SQL manipulates tables. So JSONiq manipulates something that has to be more generic than tables because we saw that it has to support nestedness, it has to support heterogeneity. So the idea of the data model is that it's based on JSON, that just like JSON, it's going to support objects, arrays, strings, numbers, booleans, nulls. But we see there's many other types that it supports. But most importantly, JSONiq manipulates sequences of items. So that's the one thing to remember from today. JSONiq manipulates sequences of items. How is that more generic than tables? It's simply that a row in a table can be seen as an object. An object is an item. So a table is a sequence of items. A table is a sequence of rows, right? So this is why JSONiq is more generic than SQL and manipulates sequences of items. These sequences can be extremely large. It can be millions, billions, trillions of items. Extremely large, but as you can imagine, it's because it's spread all over a cluster, for example, with RDDs on Spark. So sequences of items, right? So it's in the language, it's actually using commas if you want to concatenate them. All right. What's important is that it's heterogeneous. The items in the same sequence can be a huge mess. That would never happen in SQL, right? In SQL, the table will always be nicely structured with all the same columns in every row. But here it's heterogeneous. I could have an integer here and a string there and an array here and so on. And that's it, right? So it can be a big mess.
There's a question in the chat. What is the difference between sequence of items and lists?
Right, so here, the main difference, mathematically, it's the same. It's isomorphic, right? A sequence or a list. The difference is that a list is, or an array, as it would be called, is when you nest, right? So you have an array, and an array, and an array. So this is when you nest. A sequence can only be outside. It can only be the outer value that the expression returns. You can never nest a sequence, right? Never. So that's the main difference. So a sequence can have trillions of items. A list or an array can never have so many items. It has to be smaller than that. Maybe 1,000, but not more than that. Yeah. Just excuse me. All right, thank you. Just need to empty my nose. All right, so where was I? Yes, so sequences can have trillions of items. They are the outer value that an expression returns. And if you want to nest a sequence, you have to wrap it into an array, right? So you can do two things. You can wrap a sequence into an array, or you can unwrap an array into a sequence. Right. Does it answer your question?
Yes.
All right, wonderful. But again, mathematically, it's very similar. Okay. Next, it can be denormalized. What does that mean? It means that these items here can be objects and arrays as well, right? So I could have an object, so a sequence of objects, a sequence of arrays, a sequence that mixes objects and arrays, it's all denormalized. One important thing is that a sequence of one item is the same thing as that item. So if I tell you an expression returns a sequence of one array, it's the same thing as one array. If I tell you a sequence returns a sequence, sorry, an expression returns a sequence of one integer, it's the same thing as an integer, right? So we canonically identify, mathematically that's how it's called, we canonically identify a sequence of one item with one item, and sequences are flat. They do not nest, as I said. So if you try to nest sequences, it will always be flattened. A sequence is just flat. You can think as a sequence in your minds as an RDD, if you want. It's really just like these collections or the collections of key-value pairs in MapReduce. It's just something that is enormous, that is flat, that is just what scales throughout the cluster, right? So sequences are flat. All right. And items can be atomic values, strings, integers, and so on, objects, or arrays. They can also be, more recently, it's been standardized, but I'm not going to do that here, functions. So we can also pass functions as values. Why is that useful? Well, it's useful in the context of machine learning, because then you can also manipulate machine learning models in that way and pass machine learning models as part of the language. But I'm not going in there today, right? But more generally, items could be any of these four. Okay, so this is the data model. JSONiq manipulates sequences of items. What that means is that anything that goes into an expression is a sequence of items. Anything that comes out of an expression is a sequence of items. It could be a sequence of just one item. It could be an empty sequence. It could be a sequence of 1 trillion items, but it is always, always, always a sequence of items. All right? Okay. And now the beauty of this model is the flexibility, because as I said, you could have an empty sequence. You could have a sequence of just one string. You could have a sequence of integers, a sequence of Booleans, a sequence of objects. Now that looks a bit like a table, right? This is a table, a relational table. So you see that it covers tables in the same way than SQL, but it can also go, you know, here a sequence of arrays. or a heterogeneous sequence. Right. So here we have an integer, a Boolean, so it's a sequence of 4 items, fully heterogeneous. This would not be supported by SQL. If you try to fit that in a data frame, we saw that there are problems. It fits everything, hits it with a hammer and try to fit it to strings. But in JSONIC, you can manipulate that without any problem. So you see the whole spectrum allowed by sequences of items, and this is what makes the power of the language. All right. So now that we have this model, let's use JSONIC to explore data sets or manipulate data sets. So imagine that I'll start with a document of just one object for a start, and then we'll look at a JSON lines document with billions of objects. But imagine that for now, I start locally on my laptop. I have a small JSON file, and in that JSON file, there is just one JSON object. Right. Rumble can also support that. Okay, so imagine that this is my JSON file. So it's an object, it has a countries key, in there is an array, and then inside there are 5 objects that have a name and a code, right? It's a list of countries. So now I'm gonna use that and query it. So first, how do I read that? Well, I have this function JSON-doc that reads a JSON file with just one object locally from your laptop. Or it could also read it from S3, by the way, it would just download it. So JSON-doc myfile.json returns a sequence of items because it's always a sequence of items. And in that case, it's a sequence of one object that is this object right there. Now, if I start to navigate and I write .countries, what happens is that you see now this one here, I'm returning a sequence of one array. So I'm returning one array that is this big array with 5 objects inside, right? Then if I continue, I have these double square brackets. That's gonna open the array and give me a sequence of 5 items. So you see that's what I explained earlier. You can unwrap or unbox an array and get a sequence out of it. So now I get a sequence of 5 items. All right. So in that case, it's even a sequence of 5 objects. See, 1, 2, 3, 4, 5. And that's what I got with these square brackets. Now, .name, you see what's happening here? This is doing it on every one of these objects. It's navigating to .name and now returning the sequence of these 4 strings, right? If I did .code, that's what it gives to me. I can also use predicates. It's a bit like the where clause in SQL. And here, $$ refers to each one of these objects, right, in turn. And I have the predicate that tests for is the code key in that object associated with the value ch, right? And so here, that's going to filter. So there used to be these 5 objects, right? If I have countries. And then if I add the predicate, it's only keeping that one. So this is a filter. It's a little bit like the Spark filter transformation, right? And then if I continue with .name, I get Switzerland, right? So this is how it works, like a mini calculator. Now, let's scale. Let's go to a cluster that might have millions or billions or even trillions of JSON objects. Let's say it sits on S3 or on HDFS. Maybe I have 1,000 files of each 1 million JSON objects, one per line. So I can open that with this JSON file function call that is opening. So I can put an S3 or HDFS path, of course, in there. And it's going to return a sequence of maybe 1 billion items, 1 billion objects. And then I can use the syntax just normally with the filter $country equals Switzerland and .name that gives me Switzerland right there. All right. Are you following? Yes? All right. And on Zoom, is everybody following? Yes? Awesome. So let's continue to calculate with data. So now we learned how to navigate. So if I give you data on S3 or HDFS, you can open it and you can navigate it and explore it with dots and square brackets. Let's try now to construct values. So you see it's going to be very easy because constructing values in JSONIC is literally a copy-paste of JSON. This is JSONIC. It's a sequence of one string. This these are also JSONic. And the nice thing is that it's literally JSON. You can use this \n, \quote, and so on, and \u. This is JSON. There is nothing new here. This is what we studied in the JSON week. So you can literally copy paste any JSON and put it in a JSONic query, and that's going to work, right? You can also copy paste numbers, right? This is going to give you an integer. This is going to give you a decimal. This is going to give you a double. And the types here are the same that we saw in the data modeling lecture. So these types are not new, right? These are the same as in JSON and XML schema. Okay, so these are also valid JSONic query. Here it's a sequence of one integer. Here it's a sequence of one decimal, and here it's a sequence of one double. You can also get Booleans, just true and false. Again, it's copy-paste, just like in JSON. And now, this is something you don't have in JSON, but if you want more exotic types, like a long, an int, a short, a byte, non-negative integer, so any of the XML schema or JSON types, you can just use a constructor like that, and you pass a string, for example, or you can also cast from many other values, right? So you can also build these more complex types. And here you see it goes beyond JSON, because this is something you didn't have in JSON. So this is how you build special values. You can also build dates, date times, time, date timestamp, and so on and so on, right? So this is how you do it. This is often neglected in databases, sadly, or in languages, the dates and times, but in companies, this is really super important to support dates and times. All right, and there are all these other more exotic types, like for example, you have G year, that is basically just a year, 2019, for example. This is G month. So it's a bit weird syntax, but there's just a dash, but this just means that there is no year, right? So this is just November and in the UTC time zone. Year month means this is in that case 2019 November. Month day means it's November 26, but of any year, and so on. So don't worry too much about the syntax here, right? It's just to show you that there are these plenty of types that are all standard W3C/XML schema/JSON types. All right, and even durations here, right? So here you have 1 day and 2 hours. Here you have 1 year and 2 months. Here you have 1 year, 3 months, and 3 days, and so on, right? So you also have all of these types. This is not new. We've seen that in the data modeling class. You have binaries like hex binary, base64 binary. If you want to store pictures or videos or whatever, then you can encode them in these formats as well. How do you construct JSON objects and arrays? Well, no surprise, again, copy-paste. So you literally copy-paste your objects and arrays in there, and that's it. And in order to construct sequences, you can just use commas like that. Of course, that's no longer JSON here. In JSON, you couldn't just concatenate with commas without putting it in an array, right? But in JSONic, you can. So this is a sequence of 4 items, an array, a Boolean, a string, and an object, right? So comma for concatenation. A range is, as I showed you earlier in the appetizer, 1 to 100 returns a sequence of 100 integers, 1 to 3 all the way to 100, and so on. Then you have basic operations. This is boring. This is the same thing you have in any programming language, right? So you have addition, you have subtraction, you have multiplication, you have division. Careful, it's not a slash, it's a div. It has actually historical reasons because the slash was used to navigate XML in the W3C standard. So this is div. Integer division with idiv. In some languages, it would be a backslash, like in Java, I think, idiv. And you have modulo with mod, right? So these are just standard arithmetics in the way you find it in any language. Now, we need to say a few more things because the difference with other languages is that in Java or in Python, you manipulate one value at a time, right? A variable has one value, one item. But here it can be a sequence. So in particular, if you do plus, you might have on one side an empty sequence with nothing. What happens? Well, in that case, we return the empty sequence. So if you try to add the empty sequence with anything, it's just returning the empty sequence again. If you try to add a string with an integer, because again, it's a heterogeneous language, right? So the data can be heterogeneous. So you might end up adding a string with an integer. This is an error, right? This is just going to fail. What happens if now you try to add a sequence of more than one item? What if you try to add a sequence with 2 items with an integer? Well, this is an error. You can't do that. So you can either add empty sequences and then it returns the empty sequence, or sequences of just one item that must be a number, and so on. All right? Okay, you can also manipulate strings. There's a whole function library that has the typical functions you find in any language. That's also entirely standardized. It's really standardized on the W3C website. So you can concatenate strings like in SQL, so it gives you foobar. You have a concat function if you prefer to be more explicit. String join, that's very convenient. That would return foo dash bar dash foobar, right? It just joins all the strings together and it inserts this thing in between. You can look for a substring of foobar starting at position 4, going for 3 characters. That would give you bar. And string length would give you 6 right there. There's many more, right? Just to say that there's a lot of functions. Do we have a question?
Are sequences immutable like RDDs, or does every operation create a new sequence?
Yes, sequences are immutable. Sequences are immutable, you just create them. It's a functional and declarative language, right? You cannot modify sequences. All you do is create sequences and return sequences. An expression will consume sequences and return new sequences, right? So totally immutable, right? Does it answer your question? All right. And by the way, the same goes for variables. Variables cannot be reassigned. You can bind the variable to a value, but you cannot change the value of a variable, right? So you don't have any variable assignments in the language. All right. Then we have comparison. So here it's a bit like MongoDB, right? This syntax. So EQ is for equality. So 1 + 1 = 2, that returns true. Not equal. So here we test 42 not equal 42. So that returns false. Greater than. So this returns true. Greater or equal to this. So this also returns true. 42.3 lower than 7.2 returns false. 42.3 lower or equal to 7.2 returns false. Okay, so this is for comparison. And you can use that in an if then else, for example. Right? You can test for conditions and test for equality or inequality in order to branch and do what you want depending on the results. So what happens here? Well, these are a few examples. So you can compare, of course, integer to integer, string to string also works. So this is not equal, lower than, greater than, lower or equal, greater or equal. Right? So these are just a few examples. What happens with the empty sequence? You can guess. What does that return? The empty sequence, right? It's easy, it's just like for addition and arithmetics. So if you try to compare with the empty sequence using this single value comparison, it's the empty sequence. If you try to compare a string with an integer, for example, that is an error. You cannot do that. All right. But this has to be one value if you use these operators. You cannot compare sequences of more than one item. If you want to compare sequences of more than one item, then you have these different operators that have maybe the signs that you are more used to. But here, what it does is, in fact, that it looks for one match. So in that case, it's going to return true because it found the match here and here. 1 = 1, right? So be careful if you use this one, because this is actually what's called an existential quantifier, all right? Okay, so this is a match. Here, it also finds the match, and that's also true because 1, for example, is less than 2, or 1 is less than 3, and that returns true for that reason. Here it returns false because you will never find anything here that is greater or equal than something there. So this returns false. All right. And here, that's an error because it's going to try to compare 1 with 4. All right. So the reason for that, actually, because you might think, okay, why is that it tries to find the match if there's more than one item? It's for practical reasons. Imagine you have a data set like this. So you have a very big file sitting on S3 and you open it to a sequence of items, navigate to .name. So maybe you're going to get a sequence of strings, maybe 1 billion strings. And you want to test is what if one of them is Switzerland. All you need to do, it's very compact, is this sequence of billion strings equals Switzerland. And that's going to return true if at least one of the strings equals Switzerland. So this tests for, is there an object that has the name Switzerland? Right, so it's very handy. All right, so here it's even the walkthrough where this is what this returns. Then if you add .name, it switches here, and equals Switzerland, it's going to just return true because it found it right there. Right, of course, there's only 5 here, but it can be a billion, and that works in the same way. All right, here also a boring part, like in any language, there's logic. There should be no S here, and or not. I'm sure you know that already, right? It's just the typical logic that you can use in if-then-else statements. So this tests whether this is true and this is true. This tests whether this is true or this is true. And here this tests the opposite, right? This should be false if you test with not. Are you still following? Yeah, all right. So unlike SQL, it's two-valued logic, meaning that it's true, false, and that's it. There is no unknown in JSONic. You could have the empty sequence, right? But the empty sequence is not a Boolean. But it's true or it's false. And if you have something that is not true or false, it's going to be implicitly converted to a Boolean. So for example, if you test on the empty string, that's not a Boolean, right? But the empty string will automatically be considered false. If it's not empty, it's going to be considered true. 0 will be considered false. A non-zero number will be considered true. An empty sequence will be considered false. And a sequence that starts with an object or an array will be considered true. Right. So it checks for existence. For example, if you want to check, if you open a collection and check that it's not empty, then you can directly put it in an if, and that's going to check for existence. All right. So far, so good, right? So I already introduced you now several components of the language. You are able to construct items, objects, array, atomics. You can open files from S3, HDFS, and so on. Gives you sequences of trillions of items. You can navigate huge sequences. You can do arithmetics, logic, comparison, and so on. Right? So this is the start. The general idea of the language, as it is functional, is composability. That means that you can literally take any expression. I repeat that, I already said it. You can take any expression, put it inside any other expression. For example, here, let's take this example. That's, again, this calculator ID. So let's compute what it does. 2 plus 2, that's 4. Then we have blah, blah, blah dot b, right? So an object with the key b dot b is going to extract the value. Now we have an array containing an object. So the square bracket is going to pop the array open like this. Then dot a gives you 4. 1 plus 4 is 5. 5 to 50 gives you that, right? It's that easy. And that nests and that composes in any way. You just need to be careful about 2 things when you compose. First, in some way, if you don't compose in the right way, you might get a syntax error. You just need to add some parentheses if that happens. It means that the precedence, like in mathematics, you know that multiplication has precedence over addition, right? If you say 1 plus 2 times 3, that's 7. That's not 9, right? If you want to change that, you need to put parentheses around the 1 plus 2 times 3. It's the same here. If you get errors, just try to add parentheses in order to better explain how you want to group your expressions. Otherwise, this is the order of precedence. Right. So what's below has the highest precedence, and what's on the top has the lowest precedence. And what can also happen, of course, for obvious reasons, is that if you compose expression, you might get errors. For example, if you add a string to an integer, of course, you can compose strings with integers and plus, but it has to make sense. Right? If you add a string and an integer, that's obviously an error. All right, here's another example of composition. So you see how it's kind of an extension of JSON. It's like a dynamic JSON where you can put JSON, but inside you compute dynamically what's in there. So here, attributes is going to have the value 6. And here, you're creating in values an array of 10 longs. So longs are just 64-bit integers, right? OK. And this is what this is actually going to generate. So you see, this is the query. And this is the output. It's extremely intuitive to understand. Who finds it intuitive? Just checking. Who finds this intuitive? Okay. And on Zoom, let's see. You raise hands as well. Let me check. Who on Zoom finds this intuitive? I see a few raised hands. I don't know if other people are sleeping or if you don't find it intuitive, but you know that you have a sandbox online. So if you go to jsonic.org, you can type queries and see what it does. All right. Okay. So what's next? Data flow. Like in languages, you can have if then else, type switch, and so on and so on. So let's look into that. This should be easy if you know how, if you have done a bit of Python and so on. This is an if then else. So inside the if, right here, you can put any condition. In that case, we are comparing some count. So here we are counting the number of country values in file.json and checking that there are at least 1,000. If this is true, it's going to say large file. If this is false, it's going to say small file, right? Here's another one. This is the switch. It's basically, it can be done with an if then else, of course, but it's sometimes easier to do it that way. What it does is that it looks at country.code for some object, and then it goes, is it CH, is it F, is it D, is it I? And depending on the case, depending on what it is, it's going to return this, or it's going to return this, or it's going to return this or this. And if it doesn't match any of these, then it just returns the default value. This is a switch. It's also something you find in languages like Java or Python, I'm not sure. But it's very common, except that in that case, you don't, it's not imperative. You cannot give instructions. You can only say what it returns. All right. Here's another one. You can catch errors. Imagine you have a division by 0 or whatever. You can catch it with a try-catch statement. For example, you try to cast the country code to an integer, and maybe that doesn't work because it's not an integer in the string. Then you can catch it, and instead of throwing an error to the user, you instead returning that string. Right. This is also something you find in plenty of languages. All right. We have a question on Zoom. That was just a raise hands. Awesome. So it means you are following. So what's the time? Oh, this is about to be the break. Well deserved, right? So these flower expressions here, I'll do it after the break. The flower expression is probably the most powerful construct in JSONic. It's pretty much the same as the select from where that you have in SQL, right? The select from where, this is what allows you to do the relational algebra. Selection, projection, grouping, joining, and so on and so on. We look at the flower expression. It's this for-let return that you've seen before in details, and I'll show you that it can do exactly what SQL can do, but more flexibly. All right, so that's what we'll do. After the break, we'll come to this flower expression. Flower is for, let, where, order by, return. It's open. All right, so let's go get some coffee. I will need coffee too. I am a bit asleep. So see you in 10 minutes from now, and we'll take it from there with this data calculator on messy heterogeneous data sets. So see you in 10 minutes.